Alright, so for this turning example, we're going to be importing a model this time. So we'll go to File, Open, and on my computer I have this saved in a turning folder. It is a step file named Dead Center. Select it and hit Open, and you will see it opens right in Mastercam, no problem. Alright, what we need to do is we're going to take care of the two shoulders, face it, turn it, and take care of the drilled and tapped hole, and then we'll do a stock flip and take care of the tapered portion over here. So the first thing we need to do is I'm going to go to Machine, Lathe, and I'm going to select the generic Haas 4-axis lathe, the slant bed lathe. And then we can get into our stock and chuck settings. So in tool settings, I'm going to go from material. This part is steel. We can edit this for 1018, but we'll leave it there for now. The toolpath configuration, I do want my tool numbers listed sequentially, so we'll leave that alone. In stock setup, we need to get into the stock itself, and we're going to be working with a 2-inch OD stock. And length, we can choose here. We want to be as short as possible, so I'll go to 3 inches and let it, look at the screen and see what it looks like. That's not bad. I'll probably end up going, let's say, let's look at 2.75. And the reason for not hanging on to, we want to hang on to as little as, let me reword that. You don't want to have excessive material for the second operation. So we're going to turn all of this where my mouse is pointing now. And then we're going to come back and turn this. So we don't want to have a whole bunch of stock hanging off here when we're only hanging on to this 1/2-inch part, because we want a good blend line here. So we want as minimal as possible, but we also want enough to hang on to here. So, let's see what 2.5 looks like. And we could always change this. So we'll go with 2.5, okay? Because I am also going to use margins. The right margin, I'm going to leave, let's say, 30 thousandths to clean up. Okay, so that's pretty much what we're looking at. We'll grab it with the chuck here, and that should be okay. If you want to hang on to a little more, that is also okay, but just make sure that you reference that here. It's very important when we go to the stock flip that is accurate. All right, so we'll hit green check, and then we'll go to the chuck jaws. All right. And in parameters for this, I want to make sure we're hanging on the outside, and I'm going to hang on to the stock, let's say 0.625. And I want to go to preview lathe boundaries and make sure that'll work. That will work. I can actually grab onto a little more than that. So I can hit enter, get back into here, and I'm going to change it to 3/4 of an inch, preview again. All right, and I actually get a little bit closer before I get to this point where it's going to clean up. So I will hit enter, and I will change that again. Let's go 0.875, and let's see where we're at. And that looks okay. We'll live with that. Gives us some clearance from the chuck jaws. We'll hit enter, and green check. And we should be good for our initial setup, so we'll hit green check. And this is also a good time to save. So I'll hit save now, and I'll say this is dead center on the desktop. Okay. And now we're ready to assign our machine operations, all right? So I'm just going to rename this toolpath group quickly as Operation 1. And then I'll put a transition in the video here, and we will continue with the actual machining operations. All right, let's take care of facing this workpiece right now. So we'll go up into our toolpaths, go to facing operation. And we're going to use a standard, we'll use a 30,000 nose radius 80-degree insert, so tool 1 will be here. Our speeds and feeds will limit here. Just for the shop, we'll go 1,000 max on the spindle speed, all right? The constant surface speed on this one, 525, it'll be okay, because again, it is for a 1030 steel. But we're just going to go 200 for the constant surface speed on this, and we'll go an 8 thou chip load. And again, these are not optimal, but these will be a nice, safe, easy way to get this part finished. We're not looking for optimal speeds and feeds or being super aggressive with this operation, as again, depending on what class you're in, when we go to run this, we just want to make sure that we do it once. We worry about tolerances, make sure it's done accurately. I'm not necessarily worried about being super efficient with your speeds and feeds. I just don't want the part getting thrown out of the machine if you make a mistake with your depth of cuts and things like that. So this will be facing. And then we get into face parameters. Everything looks good. We're going to face to 0. We're going past an overcut. The overcut, let's go like 20 thousandths. And everything else is okay. Computer comp's good. We'll hit green check. And there's our facing operation. Okay. Now we get into our turning operation, so we'll go to a rough turn operation, and it's up to you, I guess. You know, we can get into the can cycles depending on where we're at. We'll just use a standard roughing operation. And notice when you're through the 3D model, it just goes hollow on you, so you can select your partial changes like you would if you were working in wireframe. So we're going to select here, change direction to here. Make sure it's one chain. See how it's not? Okay, so you got to be very careful of that. All right, delete that one. Okay, and delete that one. Now, partial chain, select the first entity, then select the last entity. And it makes one chain. It's very important that that happens, so be very careful when you're selecting. Okay, so green check. We'll use the same tool that we worked with before. Okay, I'll update the max spindle speed to 100, 200 surface feed, and a feed rate of 8 thou will be fine. This will be rough turn. All right, and then we get into the rough parameters. Equal steps is good. The depth of cut, we'll go to 50 thousandths. Okay, again, that's conservative, and we'll leave 10 thou on the X and Z is fine. One way is good. This part's pretty simple, so there's not a lot to worry about. The one thing I do want to make sure, again, in other videos I've focused on, is stock recognition. Make sure that is used stock for outer boundary. It's very important. And then we'll hit green check and see what it comes up with. Looks good. The only thing I want to do is extend this a little bit, because I want this transition point in the next op to meet correctly. So to extend the end of this, I go into my lead in and lead out, go to the lead out. I'm going to extend it by, let's say, 50 thousandths. Okay, then hit green check, and it regenerates. Now you might have to hit regenerate if you're using Mastercam 2021, but 2022 and newer has the generate toolpath checkbox option. So that does go past. We're good there. All right, looks good. And we're close to the jaws, but we're far enough away that it shouldn't be a problem. All right, so there's our roughing toolpath. We can take care of our finished toolpath now. All right, and we can go ahead and select the first entity. Okay, and notice it's asking us for to select first entity. What I'm going to do is get rid of that. Select here and here. One chain, good. Green check. I'll use the same tool to finish. I'm not really worried about changing tools for now. There's no need for different geometry. The feed rate will go to like 3 thousandths per rev. Let's go 1500 for the max spindle speed, and we'll increase the surface footage to, let's say, 300 for this, and that'll be okay. All right. Finish parameters. Everything looks okay. The only thing we need to worry about is the lead in and lead out. The lead out we need to extend by, I think it was 50 thousandths. We'll double check, make sure that makes sense. And then green check. Looks good. It did gouge in a little bit. Take a look here. Okay, that's something we need to reference. Get back into parameters. I will check my lead in, lead out. 50 thousandths extension. Double check. I did the same thing here. Okay, it looks good. The issue we're having is that's probably 10 thousandths because it's leaving 10 thou on the Z to finish. Okay, so the lead in, lead out for the finish pass, we can change the extension to, let's say, 40 thousandths even should be okay. All right, green check, regenerate, and we're good to go there. I don't see any issues. All right, the finish pass. All right, if I hit S and watch the cutter, perfect. Okay, and you can see by hitting S and B that it might just hit a little gouge there, but the end of the cutter does go past. All right, and we're good to go. Okay, so this is roughed and finished. Now we can, I'll do a transition there and let you catch up, and we can take care of the spot drill, drill, and tap, and then we'll work on the stock flip operation. All right, let's take care of the drilling operations for this workpiece. So we'll go to drill, and this would be a spot drill operation. So let's see what we have here for tools. We'll end up using a 3/8 spot drill for this. Let's see, I don't want to use a center drill. Let's go into the library, and let's take a look what we got here. All right, look for drilling tools. I'll hit none, drills, and green check. And let's see what we have for 1/4 inch spot drill, 1/2 inch spot drill, 3/4. All right, then we get into our center drills, which we do not want. All right. So we'll go with quarter, and what we'll do is we'll actually update it. All right. So this will be a 1 flute cutter. All right. The helix I'm not worried about. The tool geometry will be 0.375. Everything else should be okay except for the angle 118, and then we'll hit green check. All right. So there's our new spot drill. Okay. Tool 2. And constant RPM is good. We'll limit it to 1,000. Shouldn't be a problem. And everything looks okay. I'm not really worried about that. That's fine for this feed rate. This would be spot drill operation. Simple drilling, no peck is fine. The depth, this is a 1/4 So the finished diameter, we'll go like 0.260 and overwrite the depth. That's good. Everything else should be okay. Not really worried about the clearance. Looks good. Pretty simple in here. Nothing funny going on. Green check, and we can backplot this operation. Okay, looks all right. There's our spot drill. Okay, and again, I'm not worried about having the holders and things defined really well here. I am going to focus on the insert because this part is pretty simple. There's no need to really get into the full simulation. I'm really focused on the insert, and then the main goal of this video is not only working with the model, but doing the stock flip operation. So now we can get into the actual drilling op. All right, so we'll go to drill, and this is going to be a 1/4, so it's a number 7 tap drill. So if we go to the library in the filter, we should hit none. We should have the drills in there. This is it. If we get into different libraries, you can go into here, and there's all sorts of libraries available. Okay, so again, just to show you, it's the same with the milling machine. The mill default library is pretty good. But if we get into here, and you can go down and go into lathe drills, okay? You can keep, letter drills and all sorts of things like that, different brands of tools, okay? Mills, reamers, taps, you name it. Let's check out the drills. Let's see what's in here. All right. So we're looking for a number 7 drill. Okay. And it should be in order 5, 6, 7 right there. Okay, hit green check. All right, that's fine. There's a number 7 drill. All right, speeds and feeds look okay. Tool 3, this is drilling operation. All right, now the depth we need to update. The depth, okay, we'll go to the bottom of the model. So we'll just go to that point right there. We want to change this to a peck drilling cycle. The first peck will be 100 thousandths. Everything else is okay for now. The peck drilling operation I'm not worried about. Let's hit green check, and we can watch this operation run. So we'll backplot this one and hit play. We'll go transparent. And watch it run. And again, we can increase the peck value probably for this, but I'm not really worried about it. It's better not to break the drill if you're worried about it. So we're good there. Everything looks okay. But one thing you got to watch out for is what the holder settings are in Mastercam. So again, we'll backplot this. It looks okay, even if I speed it up. And just hit back or forward. So I'm hitting forward now, S. And it goes back. You can see we have a holder issue right there. Okay, and that would show up as a collision in verify. So what we need to do is update the holder settings on this particular tool. And again, that's up to you in Mastercam. Since we're running tool room kind of lathes, I don't ever really load the actual holder and things like that. But you need to be aware that, again, if you're in the Mastercam class, that's going to count as a collision. That's no good. So you need to just be aware of it. So in the tool geometry settings, all of this is okay. The only thing we need to update is probably just some of these settings. This should reference the actual drill you're using. So the overall of this drill, we'll call it 2 inches. The height to the shoulder right above the flutes will be, let's say, 1.25 and 1.125 for the length of flutes. That'll work. We'll put 1 flute for easy speed calculations. and that will work for us. All right, I'm just going to hit green check and update it, regenerate. Now, let's see if that helped our situation. So we'll go into backplot. I'm just going to hit S through this so I can see. No, it didn't. Why is that? Look at the drill in the holder. So the drill is longer, but it's stuck in the holder more. So we need to get back into the drilling operation. Go to the holder settings. All right, the overall length of the assembly, let's say, is 3 inches. And the length of the holder we need to reduce to 1 inch. That's my fault. And then the overall length of the assembly, we can just call 3 inches. Okay. Everything else is okay for now. We'll hit green check and regenerate the operation. If it did not, we can go into back, or not verify, that was my mistake. I'll X out of here. We'll go into backplot, and I'm just going to hit S, and you'll see the length of the drill now is extended, and we're not even close. Okay. But you need to make sure that this references the drill length that you want. You want to make sure that, you know, this is realistic in the software to whatever type of drill you're using. There's stubby drills, there's jobber length drills, all different types. You just need to make sure that it references something that you're using in the shop. All right, we're just going to go with this, you know, off the top of my head drill to make sure we don't crash, which is fine. This could exist, but just make sure that to avoid collisions, you're somewhat realistic. Now, one other thing, take a look. The tip of the drill is actually going to the 1 inch depth. That's really okay for this, the way it's called out. But we could always turn tip compensation on with a 0 breakthrough amount and hit green check. And let's see if we go to backplot if that helps. All right, I'm just using the S to go through. And you'll see now that the drill does actually go to the diameter created. Okay, so that's good. The drilling operation is all set, and now we're ready for the tapping operation. So it's a good time to save. Alright, so for the tapping operation, we're going to go to the drill toolpath. And I already have a 1/4-20 right-hand tap pulled up, but in case you don't, you can go to the select library tool, and you're going to have to go into the libraries, and you're going to have to find the L taps and pick the 1/4-20 out of that library. Since I already have it selected, we'll go right here. And what we need to do is I'm going to set my spindle speed at 100, and I'm also going to set the max at 100 just to be safe with the G50 line of code. And that gives us a nice easy feed rate calculation. The comment will be tapping. And then we get into the pec drill, okay? And this operation right here is going to be tap. And we can set the depth at -0.5. And that will be fine for us. Don't turn our drill tip compensation off. This will allow you to have multiple types of taps, not have issues at the machine. You have to know what the lead in on the tap is, what the it's a gun tap, is a spiral fluted tap, what is it? 1/2 inch is fine for this. Even if you're a tap like a gun tap where it pushes the chips forward, you have plenty of room on this with this type of setting, and you will have to tweak that at the machine when you get there. So we're good here. We'll hit green check, and there's our tapping operation. We can watch this in backplot. Okay. So right now what I want to do is select everything I have so far. Go to verify, okay, and then hit play, facing, turning, finishing, spot drill, drill, tap. This side of the part is now complete, okay. So what I want to do before we get into the stock flip is I'm going to go right up, create a new machine, or a new toolpath group, sorry, and this will be stock flip. And then it's a good time to save. So I'll transition here, and we'll take care of flipping this around in the program and realigning the stock, grabbing this 1/2 inch diameter here. Alright, so I'm in the Levels Manager. I've already created previously, like you saw, the stock flip toolpath group. Make sure you have levels, or should have imported in with 2 levels. Okay, one for the wireframe, one for the part model. And now we can do what's called a stock flip, which is just going to, there's 2 ways this works. It could be like an MOO code in the machine to flip it. You can put comments in, or it's just in Mastercam, it's going to signal a flip, and then we'll do a new operation, op2, and then you could just select them separately. So all the part operations to machine this part are in one Mastercam file, instead of having different files completely separate to do each side of the workpiece. So what we'll do now is we'll go to stock flip. All right. We want to select the geometry. In toolpath parameters, there's comment lines and things like that. We're not going to worry about that. But we're going to turn blank original geometry off, and we're going to go to transfer geometry, select all this geometry, hit enter. The level options, it'll automatically keep this, or make new levels. You don't want to keep the same. We want each model orientation on different levels. So we're going to offset it by 10. So if we're on 1 and 3 in the levels now, it'll be 10 and 13. I'm not going to change any of these settings right now, okay, except for the diameter of 0.5. That's what we're going to be grabbing onto. I want to show you what happens, without changing this. We'll hit green check, and you'll see our part and stock has flipped and the jaws have changed. If we go to update stock here, you can see the two different operations. Okay? So right now, we need to reposition this stock into the jaws and, or more importantly, set up to this 0, 0 point. Okay? Now, the 0, 0 is sort of up to you right now. It depends on where you want to set it. This area here, we're going to be machining this, doesn't really matter to the rest of the part, but if you face this, okay, manually to set your Z-face measure, you can then measure this distance with a mic and compensate that if you wanted to. You could also measure from here to here, know that distance and subtract it. Okay, you could also set your 0 on this face and push it up against the jaws. But then you gotta touch off the face of the jaws, assuming they're not beat up and things like that. So it's up to you. We are gonna end up putting this face of the stock at 0. All right. So what we need to do is go to levels, and I'm gonna turn off the original levels. So we have only the Op2 stock. In toolpaths, I'm gonna go back to the parameters, and for the position, the transfer position of the stock, I'm gonna go minus 2.5 because our stock, if I remember correctly, is 2.5 inches long. Hit green check. And you will see now that this is in line. Now, you have to make sure that's pretty accurate. Double check, go to the stock setup, into the stock, and you will see our length is 2.5 inches. So we'll live with that. Okay. Now, that gets us pretty close here, but again, this actual position at the lathe needs to be calculated to sync up with this edge or this edge of the workpiece. So it wouldn't be a bad idea to face this off and get it true, even if you do it manually. Bring it over to the height gauge, measure this distance, and then use that to compensate the numbers. Okay? That way, this makes sense. All right, whatever this distance is, it's up to you. This needs to be accurate, is what I'm trying to tell you. All right, this number is abstract right now. Okay? You need to know that this from here to here is a fixed number. If it's not, it needs to be that number. Okay? This program thinks that from here to here is 2.5 inches. Okay? Which means that if it's not, you need to compensate for that. All right? So, after that, what we need to do is we need to take care of where the jaws are for a more realistic simulation. So I'm going to go to parameters again. I'm going to go over to the final position and type in something like 1.875 negative. Hit green check. And you'll see it's a little more realistic. It's a little bit away. We could get that closer. It's not a huge deal here as long as you're not going to hit at the machine. We'll live with this one for now. You could get a little closer if you like. But this distance from here to here should be realistic in the machine so that when you simulate in Mastercam and it doesn't hit the jaws, it won't hit at the machine tool. All right? So that is the stock flip option. All right? It's a good time to save. Get the stock flipped. And then we'll take care of this final operation, which is only this portion. Now, we could grab up here. That is definitely a more rigid setup. It's definitely acceptable. The only issue is that we want to make sure this is running true. So, since these two diameters were turned in the same operation, we can indicate this in, and then we knowing this will be true. Okay, so these two are concentric. Put the indicator indicating on two spots, make sure it's running true. Then we'll get a nice crisp line here. Okay? Otherwise, it can be out of round. So you got to make sure you indicate in as well in the second operation. All right? So I'll put a transition here, and we'll continue with the rest of this operation. All right, so let's get ready to do a new toolpath group. This will be named Operation 2. So new toolpath group. Okay? And now we're ready. I'm going to minimize these for now. We're ready to machine this material out of the way. So let's start roughing it. Okay, so we'll rough. And we will select this geometry only and hit green check. Okay, we have our T101, which is what we're going to use for this. I will update the speeds and feeds. I'm going to take it easy with this operation. Max spindle speed of 1000, spindle speed 200 for now. And this will be taper rough for the comment. And then we get into the rough parameters. And I'm going to leave, let's say, 5 thousandths on the X and Z for this one. Equal steps. Let's go 50 thou is fine for this one. Okay, that's fine. I'm going to make sure use stock for outer boundary is on. And then we can hit green, check. All right, and you'll see our toolpath appears. Okay, we can watch this in backplot. All right, looks pretty good. Okay, now let's get into the finish operation. So go into finish. I'll X out of here for a minute. I'll turn that toolpath visibility off. In the finish operation, I'm going to go past a little bit, but I am just going to select that line, change direction. We'll use tool 1 again. The surface footage, we'll go like 3 thou feed rate, and that's fine for this. This will be taper finish. And then we get in the finish parameters. Everything looks okay. The one thing I want to change is going to be lead in, lead out. I want to make sure I lead out. Okay. I'm going to extend that by like 50 thousandths to make sure we go past. The lead in we'll leave. That's fine. I just want to make sure that it does make a crisp cone at the end, or a crisp point. The one issue we might have, the 3 thou feeder, it'd be all right. We might have to spool it faster, but I prefer that you run it a little more conservative if this is your first time running this, to make sure we don't have any major issues. So we'll hit green check. And there's our finish pass. Let's watch this in backplot. So I'm just going to hit S. So see how it comes straight in and starts? I'm not a big fan of that. It would probably be okay. But to tweak that, go back into finish parameters, into lead in and lead out. And in the lead in, change it to 135 degrees. So hit green check. And let's see, okay, how much better, or what happens here. So we're getting a tool clearance violation. Okay, that has to do, we'll ignore it for now. That has to do with this being here. Do you see what happened? So let's make that, instead of 135, let's get back into our lead in, lead out. And we could change the resolution to 30 degrees. Okay. And what we can do is, let's tweak this to 150. Okay. 180 minus 30 is 150. That should be in line here. Hit green check. And hopefully we regenerate. I'm just going to ignore the warning. And let's see what happens. Okay. Now, that should be okay. Let's see what happens in backplot. All right. Starts down here. Works its way in. Now, this is a good opportunity to bring out, notice how the tool tip is here with a 30 thou nose radius, but the tool path is here. That is tool nose radius compensation being automatically calculated by Mastercam. When running a Mastercam program, if you are using computer type compensation, you do not need a tip direction or any of that information, the radius in the COS controller. You can rely on the computer automatically doing it, which is kind of nice for any radii or any simultaneous X and Z moves. Okay, now that will work. If you want to, extend the lead in like another 50 thousandths, that's totally acceptable. It'll just take a little bit longer. Regenerate, and you'll see that we have a nice, clean finish pass. Okay, so what we can do now is we can run this in verify. Let's make sure it makes sense in verify. There's our stock. This is what it's going to be looking like. Again, we could choke up on that. We're not going to hit here. There is a radius here we need to watch out for, but this can be tweaked at any time. You just got to change that chuck adjustment. And watch it rough. And then there's a finish pass. Okay. So that's really it for this one. There is no parting operation. That part is complete. I'm going to hit save. It's good timing. So if you have any questions, let me know. Again, the syncing up of the location here to one of these faces is critical. I guess, if you zero to this face, okay, and this distance is not what it should be, if we just go to analyze distance from 0, 0 to here, along the X is 1 3/4. If it is not, you need to make sure that you reference that, okay? So if it's not 1 3/4, you need to compensate that, whatever that distance is, to this offset. okay? You could do right to the back here. This distance, the overall is 2.5 or less. Whatever it might be, you need to sync that up. It would be the equivalent of touching off the back surface. So if you could contact the back surface, then compensate 1.75". That would be what we're doing here, except for we're touching off here and compensating here. You know, so you got to make sure that you take that into account. All right. So if you know this is 1.75", what Mastercam thinks is, and it's not, you need to take account the difference between 1.75" from where you currently are and add or subtract that from your G54 Z offset or your tool lengths, depending on how you're going to adjust it. All right. So hopefully that was clear. If you have any questions, shoot me an email, let me know, and or we can talk in person. All right. So hopefully that is interesting, and I'll see you in the next one.